Lesson 12.8, similar solids. A similar solid, they have the same shape and their corresponding linear measures are proportional. So the measurements that you see in any similar solid or three-dimensional figure, those dimensions are proportional. So we'll be writing proportions today. The first example says that we're going to determine if the similar solids are similar, or if the solids are similar or not. And you can compare any types of measurements that there are. With this set being cylinders, there's not a lot of measurements to compare. So notice how I have my favorite thing out here. Anytime we have to write a proportion, I suggest out in front you make a little note to yourself what way you're going to set the proportion up. And it looks like I've got small on top and big on the bottom. So on all of these, you're going to set up a proportion, so that means fraction bar, equal sign, fraction bar. And a measurement from the small shape would go on top, and its matching or corresponding distance from the big shape would go on the bottom. So if I look at the small shape, I'm going to look at the radius, and from the small cylinder, the radius is 3. So what's the radius from the big cylinder? Oren? 4. So I would put 3 over 4. And then I got to go back to the small cylinder, and the only other measurement is the height, so that would be 2 on top. And what does that match from the larger cylinder on the bottom? 6. Now the next and last thing says find cross products. So that means I do this cross thing, and I would have 3 times 6, and I want to know, so question mark with an equal sign, does it equal 2 times 4? You do your cross products. Well, 3 times 6 is 18, and 2 times 4 is 8. So does 18 equal 8? It definitely does not. So the answer is no. It is not similar. It looks like I forgot to block out the next example, didn't I? But we'll go through it. There are 2 cones that are listed there next, and the 2 cones have the radius listed. One's 5 yards, the other one's 2 yards. And then the thing called the slant height, that's the slanted height, not the vertical height from the vertex down. It's 6 on the one and 2.4 on the other. So this time, just to show you that you can do it differently, I decided to go big to small. And from the big cone, the slant height of 6 matched the slant height of 2.4 on the small cone. The radius of the big cone was 5, and it matched the radius of 2 on the small cone. Once I got that proportion written, I did my cross products and took 6 times 2, and I had to check to see whether it equaled 5 times 2.4. And it turns out those both equal 12, so since they are equal, since this is equal, then you answer yes, they are similar. Now we're going to look at these rectangular prisms, and there's a couple of measurements listed. They could list as many as 3 on rectangular prisms like this, and then you would just have to decide on 2 sets to use. You only have to write a proportion with 2 sets. So we're talking small to big this time, and remember you could do it either way. I'm going to write a proportion, so fraction bar, equal sign, fraction bar. And somebody give me a measurement from the small prism. Okay, Oren? 10. What does 10 match on the larger prism? Morgan? 15. Now we got to go back to the small one. Give me a measurement from the small one. There's only one other measurement left, Kayla. 18. And what does 18 match from the big one? 26. So you set up this proportion with matching or corresponding parts and their measurements, and then you do this cross products, cross to cross. So 10 times 26, and you ask, is it equal to 15 times 18? Well, 10 times 26 is pretty easy. That's 260. And then 15 times 18, well, if I do that off to the side like this, 8 times 5 is 40. That's 12. So it looks like 270. And therefore, since those are not equal, what would we write for our answer? Lindsay? No, it's not similar. So that's going to be part of the assignment. They're going to give you two shapes, all the measurements filled in. You have to determine if they are proportional or not. So, or if they're similar or not. You set up proportions, do your cross products, and decide from there. Are there any questions on this part of the assignment? Or just like when we looked at similar figures in the past, you had that information and then it moves on to something else. That there is some information missing and you have got to figure out what it is. So we are going to find the missing measure for each similar pair, and it is saying we've got two square pyramids there. So we are going to find the missing measures. You are going to set up a proportion on these just like the others, except one of the spots has to have the variable. You're going to cross multiply and divide. Now notice on these pyramids, they've given us 3 measures on this one and 2 measures on this one. You're not going to use all of them. Okay? So I've got that we're going to compare small to big. To me, it just makes sense. We're going to set up a proportion. So put fraction bar equals sign fraction bar. Let's look at the small pyramid first. So we're talking this one here on the left. Give me a measurement on the small pyramid. Amber. 9. 9 from the small pyramid matches what from the big pyramid? Oren? 36. See how it's a square, so they've got 9 and 9 and 36 and 36, so really we don't need to use that other set. Okay, so now go back over to the small one. Which other measurement do we have to use? Morgan? 12, and it matches what from the big pyramid? Morgan? X. Okay, so 9 over 36 is set equal to 12 over X. Now we cross, so that means 9 times X equals 36 times 12. 9 times X is just 9X. And off to the side, I'm going to do 36 times 12. So 2 times 6 is 12. 3, 6, 7. 6 and 3. 432, and then I've got to divide by 9. That will get my value of X. So 432 divided by 9. Let's go 4 and 8. So X equals 48, and how do you think we would label this? Meters. It's not squared or cubed or anything. It's just measuring a length. So it is 48 meters. Questions on that one? All right, we're switching to cones and small to big again. So fraction bar equals sign fraction bar. Here's my small cone here on the right. So give me a measurement from the small cone. What's a measurement from the small cone? Anybody see it? There's only one number actually given. 2. And 2 from the small cone matches what in the big cone? 6. So we got to go back to the small cone. The part that's missing is the D, so we got to put D in there from the small cone. And what does it match from the big cone? 12. So 2 over 6 equals D over 12. And you do your cross cross, so 2 times 12 equals 6 times D. And 2 times 12 is 24, equals 6D. Divide both sides by 6. So my diameter of the small would be 4 yards. 4 yards. Make sure you label it with the same units. It's not squared or cubed. It's just a measurement of a length, so it's yards.